Hello, Chris Keyack here with Keyack Technology Solutions, and in this video, I'm going to showcase how to do some fixes on the Tekla Structures model after you import from MBS SlideRule. Now, this is going to be a really great video to showcase how to use manual modeling and some different techniques and strategies to do mass edits on the model as quickly as possible to get things ready for drawings. Now, this is a pretty long video, and it is a training video of a few different scenarios. So I recommend it if you want to see a very specific condition, then use the chapters on the scroll bar or go look in the description, and you can click on the links that will go to the specific topics that you maybe want to take a look at. And again, this will also showcase some areas that you may need to take a look at when you're doing a check in your model before you make drawings. And you may need to go back and adjust and modify your MBS setup and your detail methods to get a better export across into Tekla Structures. But sometimes you're under the gun, you just got to get things fixed up after it's imported in and get that job ready for detailing, and this is going to show you how to do that. All right, so let's go ahead and start with something pretty easy. I'm going to zoom in here and I can see that I've got rod bracing that's been imported in. And I can see that the name of this is brace wall and that the profile is 1-inch diameter rod that's imported in from SlideRule. And then up at the roof, it looks like this is going to be 3/4 inch rod, but rod is in the profile, and then this is called brace_roof. Now what I'm going to do is I want to filter out the model to just show these so I can quickly select them and apply the end hardware component on all of these braces at one time. Because when I look at this, it looks like the length is correct, importing in from SlideRule, but I need to apply this extra hardware custom component. Now, rather than doing that one at a time, I'm going to come in here to my selection filters, and I will scroll down until I find MBS underscore, let's see, rod bracing. So there we go, MBS underscore rod brace. And when I look at that, I'm filtering out anything that contains roof brace, brace roof and brace wall, as well as rod is inside of the profile here in the filter. So I'll apply that and say okay. But I actually need to change my view filter here at the same time. So I'm going to double click on the background. I'll then go into my object groups here for my view filters. And I'm going to scroll down here and I'm going to find the same exact thing. I've got an MBS rod brace, and then that is filtering out and only showing me bracing that has rod in the profile name, and then the name is brace roof or brace wall. So I'll go ahead and modify, and there we go. Now we've got only the rod bracing being shown. Now what I can do is come over here to my applications and components, and I'm just going to activate the brace hardware component. And what's awesome about it is it says pick part or area. Well, now that I've got everything else filtered in the model, all I got to do is window around every one of those braces, and boom, all of the hardware has been applied at the ends. And then I can just basically turn that filter off. We'll just go back to MBS no sheeting and trim and modify. And then we can take a look at that, and all of that hardware has now been applied. All right, so let's go ahead and do something a little bit more complicated. Here I've got a partition wall, and I've got basically two sets of columns on top of each other. So I've got these cold form columns. I'm actually going to go ahead and select on these, and I'm going to delete those out. So I just want to make sure I'm looking at everything here, and doesn't look like there's anything going on up top. So if I delete these out, that'll get rid of that, and maybe I'll just kind of zoom around in here, just make sure there's no clips or anything up there. Okay, so I've got that all set. And then when I come down here, there's a residual base connection there. Is there anything on the far side? Nope. Okay, so it looks like I've got everything set there to sort of get started and fix this column up. But what we can see is that there were clips that were actually attaching essentially for these girts, framing into those columns. And we're going to need to stretch those and probably just make these unique clips for the job. Now, what I'm going to do is before I'm going to fix this, I'm actually going to take a look at the rest of the model. Visually looking, it looks like that there are the same conditions in about 6 to 8 places or so. So about 8 places it looks like. And what I do is I'm like sitting here thinking, okay, if I fix this, can I quickly copy this to the rest of the model and just use the same kind of setup that I got going on here? Well, what I'm going to do is I'm going to just kind of look in here, and if I pick on this flange piece here, just on this rafter, I can see this is RF1. All right, so I'm going to go to this other one, and it looks like RF1, and just quickly getting a feel for this, it looks like the same rigid frame design is used across these bays. So I'm probably going to get a lot of replication on these columns. So I'm going to fix one of them, and then I'm going to delete the other ones, and I'm going to just copy these across and get all of these connections to update all at the same time. Now, there is the batch editor in Tekla, and I'm intentionally not using that because sometimes that takes actually longer using the batch editor here to just double check what it modifies when it tries to do the copy when you make changes across assemblies. So I'm trying to show you some strategies here of how to do this without using that batch editor, just because I can see exactly what it is that I'm changing and what I'm doing. And then I can make sure that I'm in full control of exactly what's being modified and then copied across to these other columns. All right, so if I zoom in here, basically what I'm gonna see is that I've got these clips left over and I wanna stretch those in, and I'm gonna do that on all the levels at the same time. Now, I don't want this cap plate to be in my way, so what I'm gonna do is I'm gonna see what the elevation is of this top girt. So if I say inquire assembly here, it looks like this is at elevation. See, the top level is at 16 foot 2 3/8. Okay, so that's going to give me a little bit of information that I need so I can change the view depth in the 3D view. So I'll come in here, I'll change this to say 17 foot, modify, and now the column cap plates are no longer there. So then I'll just go ahead and highlight this, say Control P, and it gets me in plan view, and I'm like, okay, where am I at? Well, it's that selected piece there where I see the dimensions. So that's the column I'm going to go ahead and zoom in on. Now, what I can see here is that I need to grab these plates. And so when I'm in transparent mode like this, so Control 2 on my keyboard, Control 4 would make me solid, but I'll do Control 2. And what I'm gonna do is I'm just gonna window from right to left, right around the corner of those plates. And if I look at the lower right-hand corner of Tekla, it says 4 objects are selected. So that's awesome. I've got all 4 of these plates vertically stacked on top of each other at different elevations for the Girts, all selected. Now, I'm going to go ahead and hold down the Alt key on my keyboard and window left to right, and that's going to grab all those work points. So it deselects the parts, and then it grabs all those handles just on the right side of the plates. Well, I'll go ahead and say right-click and move. I'll pick here as my origin, and then I'll just go perpendicular to that web, and boom, those plates are fixed and they're changed. I'll grab these ones. I'll go ahead and hold down Alt and window left to right. I'll right-click and say move, and just go perpendicular here. And again, I can control perpendicular. If you don't see that snap turning on, down here on the lower right, you can turn perpendicular and intersection on, so that way those are available for you to use. Now, I'm going to window around all these plates, okay? And so I've got these 4 objects selected, and these are no longer going to be my standard clips. So I need to change the start number to 1, and I'm just going to say CLE here for my custom clips. And then I'll just do the same thing on this one. We'll just make this CLE, and I'll change the start number to 1. So this is something important you got to make sure you remember to do, because what was happening there with the negative numbers before is it was forcing standard clips importing in from SlideRule. So if you had DT clips set up in MBS and you had basically standard part marks or standard clips, those start numbers get forced, and you want to make sure that you clear those out if you're going to make a non-standard clip scenario like we are here. So there we go. We've got that actually fixed up. Now what I'm going to do is I'm going to rotate back into 3D. And what I need to do is just finish this up by welding these together. So what we'll do is we'll just go to the steel tab here, and we'll just go to weld. Now I'm not going to focus on kind of doing exact like welds here on top and bottom. Let's say that I'm just trying to glue these together pretty quickly. So I will rotate around this assembly. I'll pick on my web, pick on my plate, and then there we go. We've got that weld input there. Pick on my plate for my web, and then I'll pick on that. And I'm picking the web because the web is the main part of the assembly, and I'm welding these clips to that, and I want the main part of the assembly to stay the web. So then I'll just pick this, and then again, I'll just repeat this on all the levels, so that way we can get this all taken care of. And then one more floor. And there we go. Now we've got everything involved with that all taken care of. Okay, so the next step is I'm gonna go ahead and increase my view depth again. So I'll just put in that back to how it was. And the next thing I'm gonna do is I'm gonna take a look at, I wanna do this basically all over the place. And I can eliminate the existing columns, and then I can essentially kind of copy these all over the place. But I wanna see kind of what I've got going on here. If I hold down Alt on my keyboard and click on one of the plates on this column, it actually highlights everything involved with that column. And when I'm looking at this, basically what I want to do is I want to copy that column to other locations. But I want to get rid of the existing scenario in the existing column locations so I can just copy and replace those. So now what I'm going to do is I'm just going to go all over the place and I'm going to start deleting these other ones. And now I don't want to have to do that manually, but one thing I did notice is that the bolts go away. Not a problem. When I copy the other columns, everything's going to copy across and the bolts will go through there on that rafter and the column. Now, there's not a lot of locations here, but I do want to quickly just use a filter, say for instance, for just to show you how that works on these. So if I wanted to filter these out real quick and just delete them all at once, I can say part name, and I'll just say select from model here. I'll click on that. That puts that frame wall column in there. And maybe we want to specifically filter out for this profile. So I'll just pick on that. And you can see these are the properties here that I'm choosing from. And then I'm just selecting that in the model. And then I'm going to do object type equals part here. So I'll just say apply and OK. And then watch this. If I window around the model and it just shows those conditions that I'm trying to get rid of, awesome. I delete those out with the delete key and that's taken care of. Now I'll switch this back to standard. And then we'll continue to go through and delete the rest of the columns. And I just got to make sure I don't delete the good column that I've done there. Okay, so I'm going to hold down Alt, select that, and then delete. And then I can hold down Alt, select that one, delete. And this is just a little bit easier and faster probably for me to do the Alt and delete rather than trying to do a filter for this one. So that's why I'm doing it this way. So let's see, let's just do Alt, select, delete that. And let's see, we've got 2 more to do. All right, so Alt, delete, Alt, delete, and boom, all those are gone. Okay, you know what? I got to tell you, as a Tekla detailer who's been detailing with Tekla for over 20 years, it's a little bit scary when I delete a whole column like that and a whole bunch of connections, but I'm pretty confident because I checked that these were all rigid frame 1, same design. I'm pretty confident in what I'm about to do. So first I'm going to hold down Alt and grab all of the parts and all of the stuff on that assembly. Then what I can do is I know that this is going to be symmetrical about basically the midpoint of this grid. And so what I'm going to do is I'm just going to rotate around and I'm going to say copy special mirror. So I'm going to pick there. I'm going to go ahead and either turn on my midpoint down on the bottom here on my snaps or right click and snap override and just quickly grab the midpoint. Now you'll notice that when I hover over the X axis that the line turns red here and it snaps to this 90 degree or this orthogonal. So I'm just going to go ahead and click on that and say, okay, and that's my mirror line, and voila. There we now have that column has been copied across. Look at that. There is the cap plate and the bolts going through there, and we've got all of the clips and everything looks pretty good. Now the only thing that, in fact, I may undo that real quick because there's something I probably want to delete on all these scenarios before I start doing the copy mirror and the copying of the rest of the columns. I can see here that the residual plates that were there before have not been deleted. So I'm going to just wipe those out, get rid of that. And then I can actually repeat that or make sure that all of these additional clips that we don't need anymore, I'll actually go to each one of the conditions and go ahead and delete those out first. And then I'll do the copy of my columns. Okay, so now what I did is I have all those residual clips deleted. I even did the copy mirror again. And so now I'm going to hold down Alt, select on my first column, hold down Control and Alt at the same time. So that way I can select my second column and keep my first selection. And now what I like to do is I know that I'm going to copy this from the center of these grid lines. So 5 to 4 to 3 to 2. And whenever you're in 3D and you're copying something as complicated as this, you don't want to come in here and pick points that are right in all of this congestion. I guarantee you're going to pick the wrong thing. And then you'll be frustrated because you're like, hey, I made these copies, but then things didn't copy into the right spot. So I'm going to go ahead and right click and say copy here. And then I'll even use the exterior of the building. So let's say I just go to midpoint like this, and then I can just go right here to the next bay over. I can go to the next bay and then the last bay. And again, here I can very quickly see without having to zoom in that I can trust that I'm going along this line and that the copies are going in exactly the right location. We'll interrupt and then let's zoom in and see if that's correct. Now, when I see that here, we'll see that these bolts copied across and they did mate with the existing rafters that were there because the bolts were disappeared when I deleted the columns out. But that copy worked because all the geometry is exactly the same on all these rigid frames. So this is a good, clean, consistent way to get those changes that I did on that one column, use the mirror, get the other column, and then just do a quick linear copy across there. And rather than individually changing all those and taking a half hour or an hour to do all that, I just did one and then copied it across because I knew that all of those frames were the same. All right, so now I'm here in an example where I'm actually already in the drawing creation stage, and look at this. This happens once in a while. You try to catch all this stuff before you get into drawings to prevent kind of what I'm about to show you. But I look at this here and I'm like, oh, okay, hey, there's this web doubler here for the flange braces coming through here, and I got to stretch this back a little bit. It's actually clashing and fouling. So I got to go fix that. Now, if you're going to fix something after drawings are made, you want to try to keep the same piece marks if possible. So I can see here by the quantity that there are 4 of these frames in the model. So I want to go find these first before I actually do any changes and run numbering again to make sure that I can keep these same piece marks if possible. Okay, so I'm back here in the model and I'm going to select on that assembly drawing in the document manager and press the select objects in the model button, which is this isometric black cube. That will highlight and show me all those assemblies. And so what's great is that these are all actually in line with each other on grid line F. And basically, these are rigid frame columns that I need to modify from grid lines 2 to 5. Okay, so what I'm going to do is I'm going to come up here to the edit menu and I'm going to measure my distance here from grid line 2 to 5. And it looks like that's 55 foot 5 here. Okay, so that's great. The reason why I'm measuring that is I'm trying to find out how much of a view depth that I need to change grid line 2 when I open up my elevation view here. How much do I need to change the elevation view down so that way I'm looking all the way across all of these grid lines? Well, what do I mean by that? I'm going to come in here, go to my view list, and I've already cut my elevation views for my different grid lines. So I'm going to find my rigid frame elevation line 2. I'll open that up and we'll actually tile these vertically here on the screen. So watch this. If I actually window around the model right now, see how it's only grabbing steel that is on that grid line 2 because my view depth here is currently set to 3 feet up and 3 feet down in that view. But what I'm going to do is we can see that grid line F is on the left. So that means I'm looking the same direction here as I am in 3D. And I want to change my view depth down to 60 feet. So I'm just going to go ahead and do that. Let's actually do 58 foot. How about that instead? So we'll say modify. I've got this view selected, so that's the one that changed. And sometimes you might actually have to do fit work area so that way it adjusts and shows everything in that frame there. Now, what I want to do is even to double check, I might actually do this and rotate in 3D. And there we go. We're just seeing those 4 frames that we need to modify. So we'll go back here. Then I'm going to zoom into this corner. And what we'll do is we'll be in transparent. So basically Control-2 on my keyboard. And what I'm going to do is I'm also going to come down here because I got welds and other stuff in the way. And I want to grab along that corner there. So I'm just going to change my selection by pressing the parts only button here at the bottom. And then what I'm going to do is I'm going to window just around that corner there. And when I do that, it highlights all of those plates across all of those rigid frames at the same time. So then I can see the quantity of objects also here at the lower right-hand corner of Tekla. Now what I'm going to do is I'm going to use that basically Alt command and just move that over. So what I'll do is I'll just hold down Alt, window left to right around those 2 grip points, use the move command, and then I'll just move this over. Now I'm just going to kind of eyeball this and see how far do I need to go. I probably need to go 3/4 of an inch or so. So I'll just do 3/4 of an inch there. And it looks like that's maybe a little bit tight to probably do welding, but at least it's clear. So maybe I can do more if I need to. Now, if I wanted to make this plate symmetrical, maybe I would actually modify this on the same side if it doesn't impact design in any negative way. And I'll just hover over there, stretch that over 3/4 of an inch, and then there we go. Now that plate's going to be symmetrical. Now, I have made that change on all 4 of those plates at the same time. So now this is when it's a good time for me to run numbering because all 4 of those conditions for all 4 of those quantity of assemblies for that piece mark have been fixed and updated. So then what I'll do is I'll come back in here and I'll go to perform numbering, modified. And then now if I go back to the document manager, we should see that I don't see a quantity decreased. So that's good news, which means that I've probably just modified the part. If I actually open this up, it's going to show me with a little revision cloud that the piece mark has changed because maybe I had some other pieces that would have worked that were a little bit wider, but I did stretch that in. I don't see the clash anymore, and I still see a quantity of 4 frames. So there we go. That's a great example of how you can basically use view depth to span across the building and get what you need modified very quickly rather than going and doing that one at a time. Now, there was one thing that I forgot to do here on grid line 2. I'm going to go back to that view and we'll just go to view list here and I will find my rigid frame line 2. I forgot to come back in here and change the view depth before I close it down. And a lot of people do this when they're kind of changing this. Also, here's another neat little thing. If I try to double click on the background, I'm like, why is my view not opening? Well, it's because I came down here at the bottom of Tekla and I chose this select parts option, which turned everything else off. And that prevents me from double clicking on the view. All right, so I'll come in here and I will change this 58 foot back to 3 foot and say modify and say okay. You probably shouldn't need to fit work area, but I'll do that just in case. Maybe rotate, looks good. Control P to get back in there. And now that view is back to how it was in case I need to make my rigid frame elevation erection drawings later on. Okay, so this is a pretty common one if you've modified your DT clip file, especially on cold form. And I noticed this on headers to Jamb connections quite a bit. So right here, because DT clip was modified and the length of that plate was changed, what you'll see here is that the bolts are actually offset asymmetrically on that. And really that tab, even though if I double click on this, it's a standard part. If I wanted to fix this and make it look correct, in case I made like any kind of shop drawings or single part drawings of this, or cut sections on my Jamb, basically my Jamb shop drawing, I want it to look right. So I'll probably go back and I'll fix this. And basically what's happening is DT clip was modified where the length was changed, and MBS wasn't really kind of expecting that. It had sort of a kind of full width probably expectation on that. So SlideRule will change the length, but again, it's just not centering that here. So we'll potentially have to come back and fix that. Okay, so what I'll do is I'll select on the plate, right click and say create view, default views of part. That'll give me 4 views here. And if my views are maximized, the last view created gets maximized with it. So I'll come up here to the window icon or button here at the upper right, and there's this small restore down button here in the middle. I'll just click that and now it shows me my 4 views. I'll close down the views that I don't need, and then I will tile here under the window, and I'll tile vertically. That way I can see in 3D what's going on, and then just quickly look in 2D. Now, let's see, what I'll do here is I'll probably do a move, and I will find the midpoint of this plate. And what I'll actually do here is I'll just grab that and then go perpendicular over here to this, kind of like that center line axis. And then now it looks like it's pretty centered. And maybe I'll just measure this real quick to make sure. So one way I can do that is I can go to the edit menu, and then underneath measure, there is a bolt spacing option. When I choose this command here, it prompts me at the lower left to pick the bolt, and then I can pick essentially the part that I want to check this against. So I'll just pick on this, this Girt here. Now, or the header. So now when I've done that, you can actually see that we have 2 inches and then 6 inches. So that's good. I know that this is probably a 4-inch center on the pattern, and we look good there. And then even if I just double check, I can measure it to the edge distance, and there's that 1.25 inches, and I know that I'm all set. Okay, so now that I got it fixed, how do I get this rapidly to other areas in the model? Well, what I can do is I can actually just save this as a custom component. The other thing that I want to check here is that the bolts, sometimes if there's a slight offset in the bolts and the holes between what's in the header or in the Girt compared to what's on the actual clip, sometimes you'll actually see that this becomes a no-hole bolt and it puts separate holes in the header or the Girt compared to the clip itself. And I don't see that here because there's no special holes. So it looks like this bolt is actually going through and putting holes in both the clip as well as the header. All right, so now what I'm gonna do, and I just wanted to check that to make sure that I'm grabbing everything. So when I window around this, you'll see that 4 objects are selected. 2 separate bolts, the clip or the plate itself, and then the weld. And that gives me 4 objects shown here at the lower right. Now what I'm gonna do is I'm gonna actually come up here to the Applications and Components panel on the right-hand side. I'll go to the pancake or hamburger button here, and I'll go to that drop down, and I'll just say Define Custom Component. Now what I'm gonna do is I'm gonna make this a connection. And you know what I'll do is maybe even for the name on this, let me just double click on this and see what it is. So this is SC79. So maybe I'll do SC79 for the name. And then what I'll do is I'll just say that it's header to Jamb. Okay. And then what I can then say is that on the position tab, instead for how this connection is going to get applied, I'm going to maybe come in here and I'm going to say that this is going to be collision plane. So wherever the secondary collides with that jamb, so this header to that jamb, that's where I want the clip face to essentially be. So again, I'll window around those objects again, 4 objects. I'll then say next, and then this is the component object. So these are the objects being created by the component. Well, that's my 2 bolts, my weld, and my tab. So then say next. Then it says pick the main part. You know what? There's actually one really important thing that I forgot to also do. I'm actually going to switch this this direction here. I'm going to switch this from auto to +Z. And there's a really good reason for that. It's so that way the cone direction will be vertical in the world, and it'll make it so that way this custom component can be actually used on the left side of the header as well as the opposite or right-hand side of the header. So I'm glad I actually remembered to do that. So I switched that to +Z here. Now, going back, let's just say next. Component objects are highlighted. Next. Main part, we'll go ahead and make that basically the jamb. Next, secondary part will be the header. And then I'll just go ahead and finish. And now that custom component is applied. Okay, so now what I'm going to do is I'm going to just go to the other side. And rather than manually moving that, I'll just delete that out. And then here underneath ungrouped items, we're going to actually be able to see and find our component. So we can either also do a search for it. So let's do SC79, and there it is. So now I should be able to just click the jamb, click the header, and boom, the bolts are there and it is offset correctly. Now, I can then basically just go to all the other openings in the model and find those, and it's a lot more easy instead of creating all these additional views like I did here and then moving the plate manually. I can just go find those openings wherever basically that header is at, and then I can just wipe out what's there and then replace that with my custom component. So again, I'll just kind of select this. There's those 4 objects. I'll just look inside of here, just make sure I'm not grabbing things that I shouldn't be. So 4 objects looks good. I'll activate my component. And then there we go. Everything looks really good as far as that being applied and all fixed up. So again, I used what SlideRule gave me as a starting point, just tweaked it, saved it, and wrapped it up as a generic custom component. There's no intelligence or parametrics or anything in there. Just wrapped that up. And by setting the cone direction to +Z, this was a really important step. It basically allowed this to be used on both the left and the right side. If I wouldn't have done that, the cone would have actually been pointing outward here, kind of away from the building. And then when I applied it to the other side, it would actually flip it upside down. And that wouldn't have been the way that I wanted to do this. So that +Z kind of helped me out. And then I can basically use this across the job. Now, I'm just doing this quickly for this job, but I could also right click and say publish the custom component, and then I could publish that as a UEL file inside my model folder, and then I can actually put that into the custom components folder inside of my firm folder, and then that way we could reuse this on new jobs. And if you put it in that custom components folder in my firm folder that I've set up for you, essentially what that's going to do is it's going to always import upon new jobs, and then you could use this and not have to set it again. Okay, so on this one here, if you ever see this is actually really important to pay attention to. So I've got this plate and I'm looking at the drawing and I'm like, what the heck is this thing out here on the left-hand side of the plate, off the edge of the plate? This is actually an example of where there are bolts that are associated with this part or holes that are associated with this part, and they're not on the material, but Tekla will still retain them and see them here. So if you ever see something like this, don't just delete the dimensions and move on. There is technically something wrong or going on in the model related to this. So I'm going to go ahead and close this down, and then I'll bring over here my document manager, and I'll select all the objects in the model and see where I can find this particular issue at. So it looks like I've got 3 locations where this issue's at, and sometimes this is actually a culprit of issues. What most likely has happened here is when you have this kind of corner plate that's supposed to deal with these bypass girts and bolt them together. I see people modify DT clip a lot for this condition, and they'll change the width or the length of the plate, and then it kind of creates some problems here. Or where SlideRule will put it in, and instead of it extending across here where it's supposed to be to bolt that up, it's kind of put it in the wrong spot. So there's a couple things that probably need to be fixed. I'm mainly going to focus on just this bolt problem though. So if you actually look in here, you can see that there's these bolts and they turn like kind of a red color or a pink color. And what's going on there is that a bolt is trying to be put in there, but it's actually not working properly. So let's go ahead and inquire on this and we'll see exactly what's happening. So it is supposed to be where these 2 plates are bolting together and the bolt is associated between those parts. But what's happening is because this bolt is away from the edge of that material, the bolt cannot complete itself or go through there. So let's go ahead and figure out how are we going to fix this. Well, the first thing I'm going to do is I'm probably going to get rid of these bolts off of this part here. And I do want the bolts to go through that purlin and potentially this clip that's here. And I don't want to lose those holes. So when I click on the bolt, you'll see over on the right that there's no special hole set. It is not it's not a no hole bolt. So what we're going to do is we're going to take this and we're going to right click and say bolt parts. So instead of having that part over there involved in this bolt, I will just click on, say for instance, the Girt, then I'll click on this clip here and middle mouse button, and now the bolt goes through. But then the holes are also in that Girt and that clip. I'll then do the same thing on this one. You have to do one at a time, middle mouse button, and then there we go. And now that's fixed. Now, technically, this plate does need to move over, and we probably need to bolt these together, especially if we want to make sure that we don't have any problems with the bolt length. Let's see, what are these A307s? Yeah, 1/2 inch A307. So I'm probably using a standard bolt length that might work on that, although those are fairly thick. But at least for now, I have separated those bolts. I've solved the issue. And if I actually came back over here in the document manager and tried to double click on that, it's going to say, hey, the numbering's out of date. I'll just go back in there. And then I can now see that, that should have been fixed. Now, why wasn't that fixed? I actually made a mistake here. I should have fixed this on all of these plates first. It doesn't look like it impacted the piece marking, which is good, but I really should have fixed all 3 of those before I did the numbering. I broke my own rule in this video. So let's actually go fix that in all 3 of the cases. So I'll just come up here, I'll just say bolt parts, and then again, I'll pick that. I'll pick the clip underneath there, middle mouse button, right click, bolt parts, pick that, clip, middle mouse button. And then again, I should have just fixed this on all 3 and then say bolt parts, there, middle mouse button, bolt parts, there, middle mouse button. Now, the reason why the quantity didn't, well, actually, I'm a little bit surprised that the number didn't change after I impacted one of those plates. But I guess because the holes were off of the edge of the plate, maybe it wasn't impacting the piece marking or the numbering. I'm going to run numbering modified here. Then I'll go back to the document manager. We'll take a look at that plate. And now everything should be all fixed up with that. So there we go. Parts modified. I'll double click on that. Come in here and there we go. Now those rogue bolts or holes are not off the edge of the plate. And we still have our quantity of 3 and everything is all set. It actually dawned on me here after I closed the drawing why I probably didn't have a change in the numbering. Well, it's because the number was forced. So again, this is something you have to be careful of and just keep a mind's eye on. Here, when I see this -301, this piece mark is being forced from DT clip coming across in the model. And so that is why the piece mark did not change, because I told Tekla to ignore the numbering with this negative number, which is then forcing the AA-301. Now, why when I opened the drawing did I still see the holes offset? Well, it's probably because the one that I fixed was not the instance of the individual part in the model that the drawing was made from. So whenever you have a multiple quantity, like here I have a quantity of 3, one of the pieces in the model is actually picked to make the drawing from. And so I just happened to have the one that was picked where the drawing was made from was not the one that I had first fixed. So that's just a good education lesson on like what was going on there. It kind of confused me and made me question what was happening. And it was because I had the mark forced. Okay, so looking at this one here, I've got a jamb coming up to a Girts. And basically things look a little offset. So I'm going to do Control-2 so I can look at what's going on. Okay, so it seems offset. Let me find out what's going on. This is a 10-inch Girts and a 10-inch jamb. Okay, I'm just wondering if like the wrong clip was kind of used here, maybe for an 8-inch member instead. And so what I'll do is first let me find out what this piece mark is, because I'm sure there's probably a few of these across the job. So DJ1 is the assembly mark. Let me do a search for that in the lower left-hand corner, DJ-1, and search, and there are a few of these. It looks like there's 7 of them throughout the model. Okay, so this is one of those cases where it's a little bit hard to kind of do all these at once unless I use the batch editor. But I am a little bit concerned. I mean, again, every time I use the batch editor, sometimes I have problems with disappearing bolts and things kind of being just slightly different. So I'm not sure if I'm excited to use this. There's pretty easy for me to see what's going on with the assembly. There's pretty standard clips, bolts, and just a standard base plate there. So let's give it a try. Let's go to the edit menu, and I will go to batch editor. It's this icon right here. If I select on that, I will then pick on, see, we're really editing kind of this assembly here where that clip is attached to. So I'm going to go ahead and select on this, and then I will choose the select option. That will grab that DJ1 instance here at the top, and then it shows me all the other ones. Now, there are warnings, so it's not like the batch editor doesn't tell you, hey, you should pay attention to what's going on here. And so if you actually click on this, it says, hey, there might be additional objects and things like that on these other ones. And so you have to kind of keep an eye out, even though these are the same piece mark. But we'll give this a shot. We'll see if I can actually use the batch editor. I'm going to throw this on the other screen for now. And what I'll do is I'll come back in here. I'll go to the view menu, and we'll get right here on top of that Girt. So we'll use the on plane command here under view. I'll then pick on the surface of that Girt, and it shows me what's going on there. Now I'm going to double click on the background, change the view depth here to maybe like 6 inches, so that way I can actually see the jamb that's going on in that connection. And okay, so yeah, it just clearly looks like this clip was actually meant for an 8-inch member because it just looks a slightly offset. So first thing I'm going to do is I'm going to click on these bolts and see what I get here. It looks like on the bolts here in the properties, this is a no hole bolt. See how the special holes are checked and this has no hole. That usually happens when MBS and SlideRule sees that there is supposed to be two things bolting together, but the holes are too far away and they're out of the tolerance check that it has to make sure that things can bolt together. It will still put the bolt in if it's close enough, like, and the two holes are there and it's close enough, just in order to get the bolt count and the quantity. Sometimes I'll see it actually put it in there, but it makes it a no-hole bolt. So if I actually hide this, let's kind of see what's going on. There it is. There's the other hole that is probably in the clip. So yep, one part there and it's in the clip. And then this hole here, if I inquire on that, that is actually in the Girt. And then if I inquire on this bolt here and say inquire, it's going to probably show me the clip and the Girt, but there's just no hole on here. All right, so we need to fix this. So I'm going to redraw this. And then what I'll do is I'll probably just window around those two bolts. And so I get the hole and the bolt. Hold down Control, window around that one. And I'll also click on the plate. And let's go ahead and see if I can move this. So I'm going to right click, say move. And what I'm going to do is I'm going to use a temporary snap reference point, because see how these are slightly offset? They're offset like in two directions. But I want to kind of keep the main bolt and the clip in the same plane. So what I'm going to do is I'm going to right click and choose define temporary snap reference point. I'll then click there and watch this. I'm going to go perpendicular, and that's the origin of my move. Now I'm going to right click and define temporary snap reference point again. I'll click there and watch this. I'll just go perpendicular and boom, it moves that across, but has everything nicely in line. Now if I hide this, let's see how the holes match up. Now there is a slight offset there, probably not going to be a problem out in the field. It'll all work out in the wash. And let's see, is this actually a standard clip? No, it's not. So it's a non-standard clip here. So maybe I could delete one of those holes and actually just match that up so there's no offset like that and no field issues or slight tolerance. But I'm going to go ahead and leave that as for now, and I'll redraw. And see the welds and everything moved across. And what I'm going to do is I'm going to close this view down that was created. I can see that it looks like everything's been fixed. Okay, I'm going to change, I'll clear out the DJ1, I'll clear out the work plane change after the view has been closed down. So down here at the lower left, I'll switch that back to model origin. And now I'm going to bring back my batch editor. So now I can see all these particular assemblies that have been like highlighted that are saying piece mark, and I made this change to this first one, and I'm going to go ahead and say copy. So now it went through and it made that change, but I need to go see if there were any problems with that. So I'm going to do like DJ-1 and see if it still highlights that. Okay, so looks pretty good. It looks like it fixed it on the top. So let's see, everything does look correct and moved across there. And then I'm just going to look, this is the kind of stuff that makes me nervous and make me not like the batch editor. So I went and fixed one thing, but then it turned off and deleted the bolts in another area. And I did not want it to do that. So now I'm going to have to undo that there, and we'll see that that batch editor change went away. And so probably my best move here is to just make this a custom component, very similar to what I did in the previous exercise related to the header connection. And I'd wrap this up as a custom component and just apply this across the model. All right, so here's another good one for us to take a look at. We've got some holes here that are right on the edge of this hot rolled member here. And we need to go find this and fix that. Let's see, how many are there? Okay, so there's 2 of these parts. So we want to find 2 of these places that we probably need to fix and take care of. And so one thing I do want to comment is that generally you don't want to wait till you get to the drawings to find this stuff, because then you got to deal with the piece mark changes or very carefully make changes. Usually I recommend to go through the model, carefully search for these areas, but sometimes you're not going to catch everything. So that's why I like showing you in the drawing that you got to still keep an eye out for things. You might catch them here at this stage, and then just be very careful at looking at the multiple quantities, going back to the model and fixing that, and then running your numbering so that we can keep as many piece marks as possible. All right, let's close this down. I'll bring over my document manager here and find out where these suckers are. So that's R2. I'll select them in the model, and there they are. By the way, if something's really small and you can't find out where it's at, you can always right-click and say zoom and zoom to selected, and that'll bring you closer to those objects, especially if they're really small clips or something like that. All right, so we're zooming in here. There it is. Basically, this member here, this Eave is coming across, and something is not matching up here for these holes, and we definitely have the wrong gauge. So let me see if I can get this kind of squared away and fixed up. Well, what I'll do is I'll actually first come up here to View, and I will say New View on Plane again. I love this command. I'm going to click on the top surface of that, and then that gets me there. Now I just got to quickly find out where this is at. So let's change the view depth maybe to, 4 inches here so I can just see a little bit up and down. There we go. There is that Eave coming across, and we can see where the issue is. Now, what I'm going to do is I'm actually going to find the workable gauge of this beam and just move those holes to that. So if I click on this hot rolled beam here, go to the profile at the upper right, we can see that this is the W10 by 15 we're using. I'll go to user attributes, and it shows me that the workable gauge is 2 1/4. So that's really handy. That's actually stored inside of that member based on that flange width. Well, I don't want to have to actually manually lay out some points for that. I'm too lazy for that. So I'm just going to come over here, and in the Applications Components panel, I'll do a search for lines. So if you created your model starting with the steel detailing model template that Tekla has in the US environment, you can use these cool construction line custom components. If you activate that, pick on your beam, what it's going to do is it's going to draw those gauge lines there for me. So that's great. Now I don't have to actually lay anything out. So I'm just going to window around those holes there, and I will move from there to perpendicular, and then I will take that and I will move those from there to perpendicular, and there we go. Now the next thing I need to do is, if I actually take a look at this in 3D, what I want to do is I need to get those to bolt through that Eave. So I'm going to right click on that and say bolt parts. I'll then, let's see, I'll keep that beam, I guess, as the first part, the second part picked here, and then now the holes are matching through that. And then the other thing I'll do here is I'll just switch this to bolt. And now I can change these all to bolt all in one shot. And then also, you know what I need to watch out for is make sure that when I turn bolt on, that this washer doesn't get turned on, since we don't use washers in these cases. So I'll just turn that off. And then I'll just, unfortunately, you cannot modify bolt parts that I know of all in one shot for multiple bolt groups. So I just have to do this individually, or I'd have to copy them. So I'm just going to pick there, middle mouse button, there, middle mouse button, and one more to go. Bolt parts, just go there, middle mouse button. So those are the 2 parts. All right, now I've got that all fixed up. And essentially, once I've got that done and everything looks good there, I can close this view down, and then I can actually come back in here and I can change the work plane at the lower left-hand corner, basically to the main global work plane again. All right, so now I'm looking at this. I do have the same thing I need to fix, it looks like, on this other side. Now, what I'm going to do here is I'm going to try to do a custom component, and I actually want you to see what it's like when you do a custom component and you just leave it at auto, and we'll see how it actually works. So I'm going to grab these 4 bolts here, and then I'm just going to go ahead and say Applications Components panel, clear out that search, define custom components. This is going to be a connection, and I'll just call it, I don't know, Eave to end wall rafter or something like that. Okay, and then I'll leave all this at auto. I'm not going to change anything. And I'll just say next. Those are the component objects. I'll make the main part the beam or the rafter. I'll make secondary object is going to be the Eave, and I'll finish up, and then there's that cone. It gets put into the model. Okay, so when I look at that, I'm like, oh, cool. I'll just take that and maybe I'll go apply it here on the other side and see if that works. So if we look at this, I would delete those out, those existing holes, and then I would try to take that Eave to end wall rafter component, and again, that's going to be under the ungrouped items. Since I just created it, I will pick my beam and then there, and it doesn't actually quite work. It doesn't put it in the right orientation. So if I look in that, we can come in here and see if like there's something we could do to maybe fix that. It looks like, you know, it's orientated to the positive Z here relative to the secondary, but I'm probably not going to get this to work. And the time it's going to take for me to figure out how to do this, like, and maybe get that cone to work, I could have just fixed this again. So this is, I kind of am showing you this sort of stuff on purpose so that way you can get an idea of the level of, should I try to mess around with the component or should I just fix this and move on? Now I am going to go ahead and take that and I'll delete those out. And I will just use the mirror command real quick and see if I can get that to actually mirror pretty well. So let's zoom in to this other side where we had this fixed. And check this out. If I go to objects and components on the bottom here, even though those bolts are wrapped up in that custom component, I can still just grab those objects and use a copy mirror to mirror these to the other side, even though those are in a component. So I'm going to just say copy mirror. And I am going to go find that midpoint there, which should be nicely here at the middle of these endpoints. I'll just pick 2 points there for my line, say copy, and let's see, did I get this to copy across very nicely? It looks good, so let's inquire on one of those. Yep, looks really good. Okay, so I think I've got that copied across. I can't remember if I deleted the holes. I did from before. And so at this stage, I did do this other custom component that I had in here, this Eave to end wall rafter. And sometimes it is worth it if you have lots of cases. Sometimes you may just have like a kind of like an opposite hand case like I have here. So here's what I'm going to do. I'm going to take these bolts and I'm going to go ahead and define another custom component. And I'm just going to call this Eave to end wall OPP for opposite hand, right? So sometimes you just make an opposite hand and then you can use it on the left or the right side of the building, and then that's faster than you trying to mess around and figure out what's going on and why you can't make one universal custom component. So I'll just say next, component objects, main part, next, secondary part will be that Eave, and there we go. Okay, so I think I've solved it for these 2 parts, but what about the other side of the building? It looks like that Eave is going on this end wall as well. So if I just come in here, what I'm going to do is Control 2, I see those holes. I'm going to get rid of those as well, and I'm going to use my component. Now, in this particular case, I bet you the opposite's going to work on this side, so I'll pick here, here, and looks like the orientation and the rotation of those bolts is spot on. Looks really good. Okay, so I'll go ahead and keep that, and then I'll go to the other side, and we will just fix this up really quickly. I'll grab these, delete those out, and then I'll use the original one that I made. I'll pick the Rafter, and then I will pick my Eave, and there we go. Now that's fixed. I come up here to Drawings and Reports, Perform Numbering, go back to my Document Manager. I should see the 2 parts that were involved with this. Both of those are shown as modified, but they have hopefully not changed their piece marks or their quantities. I didn't see an automatic clone, so I think we're good. Quantity of 2, very nice. The holes are fixed. The dimensions are shown as being adjusted correctly. And there we go. We've got that nice 2 1/4 gauge and quantity of 2 on both of these. For additional training and setup and configuration of MBS SlideRule with Tekla Structures, please reach out to me at my contact information shown, and I'd be glad to help.